Welcome to Old Iron Machine Works. I hope everybody out there is staying safe in these crazy times. I know a lot of people are forced to stay home. The company I work for, we're still going strong. We are in the natural gas business, and I guess people need their natural gas. This is an engine we're overhauling right now, which is a Waukesha 3521. And this video will be just a few random jobs that I had going on over last week. Yeah, this particular job here, I think just about everybody at the shop has had their hand involved in working on it one way or another. Here's my coworker Cliff. He has definitely did the majority of the working on this engine as far as the teardown and reassembly. Here I needed to do some work on the front bearing thrust plate. What happened is it sheared a couple roll pins and it let it start spinning and kind of wore between the crank and the gear. Here I'm taking a light cut, screwing it up a little bit, and then it'll go on the lapping table. Here you can see the divot marks from when it sheared off the roll pins and spun. It means nothing. That part there, once the roll pins are in, will pull up tight against the crankshaft and it won't spin. Here's the other side. That's the part that actually went up against the crank, and when it spun, it just kind of gave that little wear pattern. I'm just going to clean it up. Here I'm just stacking a few miscellaneous things up on the front of the crank. What you want to do is you want to put that thrust spacer or the thrust wear plate up against the bearing, and then you want to sandwich it nice and tight against the crank before you put the gear on. That way you can check your in play, and once you know your in play is okay, then you can go ahead and heat the gear up. There's the 2 roll pins that anchor on that thrust plate and keep it locked to the crank, and it's supposed to keep it from turning on the crank. I needed to add one more spacer on the front of the crank in order to tighten everything up. Here I'm just parting off an old pipe fitting that I machined inside out on. I don't think I've ever showed this. Everybody's got their different ways of setting the height of their cutters, and the way I do it is I got that little level there. I just crank it around to where the bubbles are, where it's level, and I got a small little groove that I just ground with my little Fordham tool, just a slight little mark. And as long as the level's level, no matter what position the jaws are going to be in, you know, it's always going to be true to center line. Here it's showing pretty much got everything back together, got the thrust plate in. I was able to tighten everything up and had my correct in play. So at that point, heated the gear up, put the slinger on, and making progress. We had 2 rocker arms that had an issue with the bushings, so we went ahead and swapped the bushings out. And normally you would hone them to size. We did not have the correct mandrel hone to do the 2, so I just went ahead and did it in the Bridgeport. The bushings have oil grooves, but they kind of corkscrew in, so you can't drop the needle on the test gauge down inside, you know, without it crossing over it. So here I'm just going to machine a little dummy that drops in just for centering it up with the indicator. Here I'm making my final cut to size, and I'm actually pulling the cutter, you know, back away from it. I wanted to leave that little teeny lip, just so when I go to slide it in the rocker arm, it doesn't fall through. Here I'm using my level gauge again for setting the cutter. I don't have a whole lot of tool holders, so I do have to switch out tools fairly often. Here I just got a smaller boring bar in there. One thing about any kind of jig or any kind of machining, if you can machine all your critical spots without ever removing it from the chuck, it's going to be the most accurate you can get. Basically here all I'm doing is just making truing up a cut just to where it's running true with the outside dimension, just so the needle on the indicator can run true on the inside. These bushings actually run a 2000s clearance, so they're not really tight tolerance at all, but they are pressure fed rock berms. I had to end up taking right around 6 thousandths off the bushings in order to get my 2000s clearance. Here's the completed rocker assemblies. Here we have the crossover stands, and what these are is you have 2 intake, 2 exhaust valves per cylinder, and the crossover stands drop down on a pilot, and then you basically adjust one side, to where when the rocker arm goes to open them up, it's opening both valves at the exact same time. Here I'm just having to come up with a way of clamping it up onto the Bridgeport table to go ahead and clean up the pocket areas where the valve stems sit in. Here I got to go in and clean up these pockets that sit on top of the valve stems, and over time they get some wear, and you can see a little shoulder in there. I just got to go in and machine that little shoulder out where you have just a nice clean square area to sit on the valve stem. Here I'm just clamping it to a piece of high-speed steel. It's already got a hard tempered spot right there. That's the only part on these that's actually hardened in any way. And then I just need something to clamp it down nice and tight, and then just go in there and clean it up. I do all the piston, rod, packing box, valve work in the shop, and that's just a pile that goes to the same unit. We're kind of going through the entire compressor also. That's just a whole bunch of old packing pieces and new packing kits. And here I'm just starting to put them together. Here I'm getting ready to polish the rod up, and now I only have one little cheap little iPhone stand, and I had it at home. So here's the belt polisher. I had to put in an old footage of me polishing something else up, just so you can kind of get the idea how it works. We had a customer lose an 817 engine in a fire, and they needed to buy another engine from us with a twin disc clutch that they can disengage mounted to it. We had everything except you can see the clearance. That's not going to work. I needed to go ahead and do some machining in order to mount the twin disc up to the engine. Most of the footage you see on my videos are me machining at work. Here, the lathe I had at work was not big enough, so I did bring it home to my home machine shop and put it in my large Regal lathe. What the nylon's doing is just holding the flywheel tight up against the jaws. So as I'm dilating the flywheel, it's always keeping it pushed up tight on the jaws and don't have to worry about it, falling out. I've always said, and especially with the larger mics, put a big mic in half a dozen guys' hands and you'll probably get a half a dozen different sizes. Here, if you look at the mic, I had to end up going, if I remember right, 130 thousandths past the end of the mic where the mic kind of stopped. Here's an old tool holder I found on eBay quite a while back, which for now it works, but you got to shim your cutter up and down. So eventually I want to get one of the big boy Laura style tool holders for my big lathe. Years ago, I had a big old monster LeBlanc lathe that was designated it did nothing but flywheels, cut and ground flywheels, just because they're so nasty, and I hate that material getting on my lathes. This is the ring that the clutch drive plates actually drive off of, and I wanted to have a little bit more support on it. So what we got here is I found another steel plate that was machined perfect for an 817 flywheel, but it was machined where a drive shaft is bolted to the center. And here I'm just going to cut the center of it out and then machine it to fit snug on that drive plate. Just cutting the center out so I have less machining I got to do. I needed to keep the ring set out a little bit to give me some relief area for my cutter when I go to machine the inside. And what I'm doing here is I just got that little precision chunk of steel there, that I'm just using as a gauge to just get the outside lined up, flush. had a heck of a time keeping the reflection off my tile indicator, so I had to hold the thing over the top of it, you know, so you can see it. The slight movement you see on the needle as I go in and out is just the machining marks, you know, from the previous, you know, machine work that they did on it. I wanted to have a slightly snug fit, and I ended up getting slightly a snug fit. Here I'm using the original holes for my pilot holes, 25/64 bit, fit perfect. So it basically just gives me my countersink marks underneath on the flywheel. Once you have your countersink holes, now I'm going to drill with the 5/16. Commit to the hole. Once you start to go, take it down, keep pressure on it, it'll drill you a nice straight hole. If you get a little timid with it and start going easy, any kind of run out you have in the bit will end up wobbling around, and now you won't have a true hole. Here I have the tap shoved up into a tap socket, and all I use the drill press for is to start the tap, and then I go over with the tap handle and finish them off. All installed and ready for paint. Hello, Adley. Hello. This is my daughter, Adley. She is helping me do some welding for the hashtag Coat Hanger 2020. I should point out this is the first time Adley has ever welded with a wire machine. Very nice, Adley. If you like this kind of content, please give me a thumbs up and let me know in the comments. Anyway, thanks for watching.